Good evening, everyone. Welcome to O-Level Physics Revision. We'll be going through the 2012 structured paper today. My name is Mr. Chu. Today is 4th of October, Tuesday. Let's begin. Okay, start doing question 1A quickly. I'll be doing together with you. Okay, Oscar, well done. Is your accuracy okay? Ryan, why you show the answer to everybody? Yiting, your answer, you should put the accurate answer first. Then after that, at the end, you put the bracket to how many significant figure. Okay, how about the rest of you? Oscar and Pei Kwan. Okay, Pei Kwan, well done. Okay, those who are done can also do part B. B is very simple. Oscar, what's your answer, Oscar? Pei Kwan, your B is correct. Well done. Okay, so I would like you all to write this down very clearly. Okay, for part 1A, okay, I want you to write down acceleration is equal to gradient of a speed time graph. Can? So I want you to actually write this down so that you let the examiner know what you're trying to do. Okay, because you're supposed to use the data from the graph. Okay, then you write down equal to rise over run. In this case, is 25 or minus 20. The run, this is 10 and this is 6. Okay, so it is 10 minus 6.0. Okay, so from there you will get 1.25 and then at the end you write down 1.3 meter per second square and then write down the significant figure. Is that clear? Okay, so in your working, I want to see the exact value because this value may be used in another part of the question. You don't use 1.3 in your other part of the question. Then your final answer, please write down the significant figure. Oh yeah, Oscar, you got it correct. Hey, sorry, Oscar. Sorry. And who's the last student? Hao Rui, what's your answer, Hao Rui? I'm sorry, Oscar. Okay, the rest of you write down. What is the answer for B? Okay, Ryan, well done. Pei Kwan, well done for B. The rest of you, what's your answer? Hao Rui, are you there? Hao Rui. Okay, well done, Hao Rui. Okay, so most of you are able to do part B. Let me just quickly write down to you. Okay, area under the graph of a speed time graph is the distance. So it's the distance traveled by the car from time equal to 10 seconds to 16 seconds. Okay, so that is the specific. That's how you can write down specifically. Understand? Okay, let me continue. Okay, so quickly tell me what is average speed of the car? What's the meaning? Okay, let me just give you the answer quickly lah. Okay, average speed is not distance over time. It is the total distance. Okay, not the average distance, Ryan. It's the total distance traveled. Okay, over the total time taken. Okay, the keyword I want to see is the total. Okay, so average speed is the total distance traveled over the total time taken. Okay, that is the main thing I want to see for this 1 mark. Okay, so as you can see, from 6 to 16, which is this, versus 0 to 20, which is this. Why is this average speed higher compared to the average speed here? Why is the average speed higher here compared to the average speed here? Actually, I can tell, right? From 6 to 16, the speed ranges from 20 to 25. So the average speed is okay, somewhere between 20 and 25. Same thing. For average speed from 0 to 20 is also between 20 and 25. So why is the average speed from 6 to 16 be greater than the average speed of 0 to 20? This one, all of you should know, right? Even primary school students should know. Okay, so I will not go through this. Anybody need me to explain part 2? Don't need. Okay, so you all go and explain yourself. Okay, suggest why would the average speed here be greater than average speed here? Okay, let me continue. Okay, we'll just keep a lot of questions. Let's do part B now quickly, everyone. Okay, everybody do part B now. Then for A and C, any of you need me to go through, let me know. If not for this question, we'll just go through B. Well, ran so fast, I haven't even count yet. Okay, Ryan, is your answer too specific? Hooray, well done. Oscar, is your answer too big? Sorry, too accurate? Oscar, if you put 19.0, that is not 2SF. Okay, better now, Oscar, but can you put the bracket 2SF? Thank you. Yi-Ting, well done. Who else? Who else? Okay, well done, Oscar. Well done, Yi-Ting. Well done, Hao-Rui. Well done, Ryan. Bei Kwan left with you. What is your answer, Bei Kwan? Bei Kwan, you need help? Okay, the rest of you, do you need me to go through A and C? Anyone? Yeah, I'll not wait for you, Bei Kwan. If you need help, let me know. If any of you need me to go through A and C, please tell me. Okay, so most of you should get 19.2 joule. And then because of accuracy, you put 19 joule to 2 SF. 19 joule is very little energy. Imagine you are a person with a mass of 60 kg and moving at this speed. Your kinetic energy is just 19 joule. 19 joule is very little, if you realize. Okay, Bei Kwan incorrect. What's the formula of KE, Bei Kwan? Formula of KE is half mv squared. Okay, you sub in. M is 60. Your V is 0.8. You sub it in, you should get this answer. Okay, Bei Kwan, try again. Okay, good. Anybody else want me to explain A and C? Give me some reaction, yes or no? Yes, give me a yes reaction. No, give me a no reaction. Hurry up. Quickly, give me some feedback. Okay, let me continue. Only two of you give me reaction. Can you be a bit more responsive the next time? Wow, third question is really on electromagnetic spectrum. Okay. Let's do this quickly. Do A and B1. How well done? Write the question number, then your answer. Ryan, do A and B1. Bei Kwan, there are other wave that are transverse. For example, water wave. So you cannot say that the electromagnetic spectrum is a transverse wave that is different from other. Okay, Oscar, well done. Ryan, well done for part 1. Sorry, part B1. Ryan, well done. Okay, Bei Kwan, your A need to change. Yi Ting, your A and B are correct. Hao Rui, B1 is correct. Okay, Bei Kwan, your B1 is correct. Okay, so what's the one property that distinguish them from all other wave? Okay, so they actually travel at the speed of 3 times 10 the power of 8 meter per second in vacuum. Okay, so this is the characteristics of the electromagnetic wave. And only they travel at this speed in vacuum. Is that clear? Okay, most of all of you got part B1 correct. So let me write down the answer. So what you see is visible light. What you feel, the heat, is the infrared radiation. Is that clear? Okay, so the current in the lamp is reduced and the color change from white to red. They only ask you to describe the change in the radiation emitted by the lamp. They did not ask you to explain. Okay. Okay, so the current in the lamp is reduced. So you just mentioned that when the current is reduced, okay, when the current is reduced, the brightness of the bulb will be also reduced. Okay, so that's why I put the brightness reduced. Then the color change from white to red. What can you say about this? Okay, when it changes to red, it shows that the wavelength of the visible light that is being emitted by the lamp are primarily in the red spectrum of the visible light. Is that clear? Okay. Which part you want me to explain again, Ryan? You need to describe the changes in the radiation emitted by the lamp. Okay, so when the color is all red, it just means that the visible light that is being seen are primarily from the red part of the visible light. Okay, so let me just move on. Okay, let me just quickly explain this one to you. Okay, how the energy is lost from the metal filament by conduction. Okay, how to explain this? Okay, so let me just explain. You all just listen. Okay, if not, you'll take a long time to do this. Okay, so you can see the metal filament is here. This is the metal filament. Let me just highlight to you. Okay, this is a metal filament. Okay, so the metal filament will generate thermal energy. Okay, you emit thermal energy. So it will be conducted. Okay, how? It's conducted down the metal support. Now here, can you see? Metal support, then to the glass support. And then it will be lost through the base of the, it will be lost through the base of the bulb. Is that clear? Okay, so for conduction, they must be touching each other. So the thermal energy is conducted down the metal support to the glass support and then lost through the base of the filament lamp. Can? Then how is it actually being lost through radiation. Okay, the second part of the question is by convection, not radiation. So this one is a 2-mark question. Okay, so inside here, you also need to touch the metal filament. Okay, you need to touch the metal filament. But in this case, where for convection, there is a movement of the item. Okay, so how do you explain? The nitrogen gas near the metal filament will gain heat from the metal filament. Okay, gain heat, expand, become less dense, and rises. Okay? Then it will actually come into contact with the glass casing and transfer some of the thermal energy to the glass casing. Okay, the glass casing here. Okay, which will end up heating the air outside. Is that clear? Then the cooler nitrogen gas will rise. Again, you will gain heat from the metal filament, expand, then density actually decreases and you rise to the top again. So this is how you mention about the convection. So you just go up and down, up and down, up and down. Clear? All right, let's continue. Next question. Now, all right, so all of you now do 4A. Okay, Ryan, correct. Yi Ting correct. Hao Rui correct. Okay, Oscar, well done. Bei Kwan, well done. Okay, all of you are able to do this question. Very good. The answer will be 0.0018 gram per cm cube. Okay, because they are all packed in a smaller volume. Okay, they are all packed in a smaller volume. Okay, so therefore the density should be greater. So if you count, if you go and calculate, you give me 0.0008. Ask yourself, the same number of particle packed in a smaller area, will it be a greater or a smaller density? Okay, so in this case, your answer should be greater than this value. That's how you check. Is that clear? Okay, so for part B, okay, I will skip B and C unless some of you want me to explain. You look through these three questions, 1 minute. How many of you want me to explain B and C? Okay, nobody want me to explain this, so let's continue. Okay, very good. So everybody do part A. When did it become completely solid? Eating, okay. Okay, Bei Kuan, well done for A. Hao Rui, well done. Okay, Ryan, Ryan, okay. I will accept your answer. Okay, who's the last student? Who is the last student? Oscar. Oscar, are you there, Oscar? Okay, why is this sample losing thermal energy throughout the experiment? Do you agree that the sample is losing thermal energy all the time? Okay, do you agree? If you agree, you have to agree lah. That's what the statement is saying. Explain why. Okay, explain why it's losing thermal energy throughout the experiment. Yuting, is throughout the liquid, but you only mentioned 100 degrees Celsius. Well, Ryan, when was your practical? Okay. So anybody else has given me the answer? How Ray, I will give you the 1 mark. Yu Ting, you need to I did a bit more. You don't write down 100 degrees. You must write down something else. When the graph gradient is going down, then it's negative. When it's going up, it's positive. You think it's better? Is that much better? Okay, why the sample is losing thermal energy is because throughout the experiment, the sample has a higher temperature compared to the laboratory temperature of 20 degree Celsius. Is that clear? Okay, throughout the experiment, the whole experiment, can you see here in this 120 seconds, the sample has a higher temperature compared to the laboratory temperature of 20 degrees Celsius. Okay, so why would this explain that it's losing? Okay, when there's a difference in temperature, thermal energy will move from a region of higher temperature to a region of lower temperature. Is that clear, everyone? And Yiting, you use the word liquid. That is wrong again. Okay, that's wrong again. It's not it's only liquid from 0 to 95 or 96. Okay, after that become here onwards, 30 onward becomes solid already. Okay, so Yiting, don't write the word liquid. Okay, any questions so far? Let's continue. Okay, this is a very good question, number C. Explain why the temperature of the sample is constant here. Yes, it's always losing thermal energy, but the temperature remains constant. Why? So can you all write down? This is a good question. If it's gaining heat, I think you all know how to explain. But if it's losing heat, see how you explain. Because it's something that is not easy to explain. Even though it's just the opposite. Okay, but it doesn't make sense. So just try and show me your answer for part C. Okay, part C is a 2 marks question. Okay, start doing now. incorrect, 北关. Throughout the 120 seconds, thermal energy is lost throughout the experiment. Okay, at all time, even when it's flat, thermal energy is lost to the surrounding. Okay, so your explanation is saying otherwise. So can you try to explain? Yes. You say that heat energy is used to change the state of liquid, but you're losing heat energy. But what you're mentioning is you need heat energy. And then what's happening is heat energy is lost to the surrounding. But you mentioned that instead of being lost to the surrounding, so your part C is not correct. Can you think your answer a bit weird? Okay, Ryan, you got a bit of you got it correct at a certain part. My explanation can be a bit clearer. Do you all feel confused on this kind of question? If it's a solid melt to become liquid, right? Easier to explain, right? So now it's opposite. Liquid actually freezes or solidify to become a solid. It becomes a bit weird already, right? Yeah, just remember lah. Just write the opposite of melting, then you should be fine. Okay, first of all, you can explain why the temperature is constant even though the thermal energy is reduced. Okay, the thermal energy is reduced or thermal energy is lost, but why is it still constant? Okay, first of all, you must mention for substance itself, they are both kinetic energy and potential energy. Is that clear? Okay, kinetic energy deals with the temperature. Potential energy deals with the bonds. Okay, so how do you explain this? Okay, how do you explain this question? Okay, so you can write down the temperature remains constant. Okay, as there is no change in the kinetic energy of the molecules. Is that clear? Okay, the temperature remains constant as there is no change in the kinetic energy of the molecules. Yeah, however, as the intermolecular bonds are being formed during freezing, the potential energy of the molecules decreases. Okay, you understand what's happening here? Okay, let me just explain what happened when things melt. Okay, when things melt, what happened? Okay, when things melt, energy, okay, when you supply thermal energy to a substance, okay, during melting, okay, melting, let me just draw melting like that, okay. So during melting, the kinetic energy of the molecules remains the same. So temperature remains the same. However, thermal energy is taken in to break the intermolecular bond of the liquid to become solid. So now you say the opposite. Okay, when it is freezing, okay, when it's freezing, okay, when melting, the intermolecular bonds are broken. So during freezing, the intermolecular bonds are being formed. So you say the opposite. Then during melting, thermal energy is needed to break the bond, right? So during freezing, the potential energy of the molecules decreases. Are you all now less confused? Because this explanation also confused me my whole life. But you just need to write the opposite. Then when you write the opposite, it makes sense. Correct? Cannot be freezing also take energy, melting also take energy, ma. Okay, when you need energy, you need heat to melt. Okay, you will lose heat when you freeze. Okay, it should be the opposite. Is that clear? Okay, why it doesn't make sense is because a lot of you think when you form something, you need energy. Okay, when you form something, you need to put effort. Correct or not? When you form bonds with your friend, you need to make effort to talk to go out to share things together. But in this case, when you form a intermolecular bond, you actually lose potential energy. Okay, understand? My explanation make it a bit clearer to all of you. Okay, if it's helpful, give me a yes reaction. If it's not helpful, give me a no reaction. Wow, Ryan, give me a heart. Okay, so clear so far. Very good. Let's continue. There are more questions here. So a test tube containing an identical sample of liquid 100 degrees Celsius placed in a beaker of water that is kept at a temperature of 90 degrees Celsius. Okay. Who want to draw this? How Ray? Can you sketch something on this graph to explain part D? Wow, why so many drawing one? This by who? How Ray? This one? Okay, very good. Okay, the part here, make it straight, and then not so straight, not so nice. Okay, let's continue. Let's continue. Okay, this one is the lens question. Okay, who want to draw this? Okay, let me ask Pei Guan. Can you do part A? Let Pei Guan try first. If Pei Guan cannot do, then Ryan back him up. Pei Guan, you try first. Mm-hmm. Okay, the rest of you do part C. State the two changes. Okay, state the two changes. Okay, Pei Guan, why you draw the principal axis and the lens? You're supposed to draw the rest, eh? Hello. Hey, Pei Guan, if you need help, type help in the chat. I don't know why you just draw these two lines for what. Hello, Pei Guan, are you there? Okay, Ryan, you take over. Draw the two ray from the top of the object to locate the image. Yiting says become smaller. Oscar say become bigger. Ryan, your focal point is wrong. It's 4 cm. Can you see here? One big box is 2 cm. Okay, one big box is 2 cm. Half the box is 1 cm. Then who draw this? Pei Guan. Okay, Ryan, you continue doing. So I don't know whether Pei Guan is still trying. Ryan, you use another color. Don't use red. This is not F, Pei Kuan, this is 2F. Because the focal length is 4 cm. Yeah, correct. Sorry, I'm sorry. This is the correct focal length. You're right, correct. Continue from there, continue. Okay, Ryan, you can also draw, but use a different color. Pei Kuan, you continue. Hey, why you take so long? Fasterly. Okay, Yiting, your two changes is correct. Oscar, your two changes is wrong. Can you try again? Hey, you take very long. Hurry up. Hey, Ryan, are you drawing or not? Hey, Kwan, are you still doing? Oscar is now correct. Do you know your mistake, Oscar? Ryan, okay. Okay, let me just do this question. You all are taking way too long. Okay, first of all, from the object, you draw a line. Let me choose another color. I use blue. You draw a line from the object to the center, through the center of the lens. Is that clear? Okay, that's the first step. You draw through the center of the lens. Okay, and then you can extend. Okay, right? You remove your thing first. Okay, then next, you draw perpendicular to the principal axis. And then you draw a line that actually cuts through the focal point, like this. You cannot erase. Okay? So, moving to the front, it will never converge. So, you must actually extend the line to the back. Is that clear? You must extend it to the back where it will converge. Okay, the key thing is this point here are all dotted line. Are all dotted line. Okay, so your image will be at the back here, like this. Can you see? This is your image. Okay, here must be dotted line, dotted line. So your arrow will be like this. Your arrow will be like this. Is that clear? Okay, that is how you do part A. Part A, and then image is at the back of the object. And because here is all dotted line, because when it move forward, it diverges. It doesn't converge. So moving backwards, it should be dotted line. Okay, touching this point. So this is a virtual image. Understand now? So, how to do the next question? Let me use another color. I use green. I move the object closer. I put it here. Okay? The ray on top here is the same. The second ray here, like this, is different. So what happened now? Where would it will still be a virtual image, but where would the image be? If I move closer, my image should be somewhere here, this green line on top. So you compare this one and this one. Can you see that it is actually closer to the lens as well as it is diminished? Can you see that now? So Oscar, if you do not know how to do, just draw on the screen, draw on the paper, you can see a difference. Okay, so you'll be what? The image will be closer to the lens. And number two, it will be smaller. Okay, the image will be smaller. Are you all clear about this question? If you understand, give me a clap. Okay, if you understand, give me a clap. Is it helpful? Okay, Ryan, why your camera spoil again? Okay, let's do the next question. Okay, let's do part A, everybody. Then do part B. Write down the answer A and B. Okay, I got my answer for A already. I got the answer for second one as well. Okay, how Ray, your A is correct. Can you write down A, the answer? Okay, Yi Ting, your A is correct and your B is correct as well. Well done. How Ray, your B is correct. How about the rest of you? Ryan, Bei Kwan, and Oscar. Sorry, Oscar, you just give me the answer. A, correct, well done. Well, how you do the ohm sign? Very good. Okay, Oscar, well done. Bei Kwan and Ryan, where's your answer? Okay, Ryan, well done. Can I have Yi Ting do your working for part A on the screen? And who have I not called? Oscar, you do the working for B. You think you have to use this formula. Oscar, what's your answer for part B? Bei Kuan, your B is incorrect. Your A is correct. Okay, the formula that I have been teaching you all for parallel will be 1 over resistance total is over 1 over R1 plus 1 over R2. Okay, this formula is more generic because you can do 1 over R3, 1 over R4 and continue. Alright, this formula is only up to two branches. Okay, you can't do 3 or 4 branches, right? Maybe can just multiply all. Okay, but this is a generic formula. Okay, so when you do this, you'll get the answer 24 ohm. Okay, well done. Okay, then for part B, Oscar, are you able to give your answer? Okay, very good. So therefore the answer is 0.25A. Okay, so for this one, why the potential difference between point A and B? Why is this A and B? If I were to put a voltmeter here. Okay, why is this 3 volt? Yeah, you can see from B to the top here is the same potential difference as the battery, which is 6 volt. And because it is divided by 2 equal resistor, so the potential difference between the 2 resistor will be the same, will be equally shared. Okay, so the 6 volt is equally shared between the 30 ohm and 30 ohm. So therefore this is 3 volt. Understand? Okay, I will just move on. Okay, so now more calculation. Can you find the PD between C and D and A and C? A and C. Okay, you all try and do now. Write down write down part 2, what's your answer? Part 3, what's your answer? Let me also go and calculate. Okay, I got the answer for both already. How about you all? Ryan, well done. How about the rest of you? Yiting, well done. Any more? Okay, so you all know that below here are all 0 volt. So this is 0 volt, this is 0 volt. So you know that A is 3 volt. Okay, continue. Hooray! Part 2 correct. Your part 3 then? Okay, the rest of you, where are you? Okay, so let's assume this to be 100%. So if I were to break this into these two parts, can I say that this is a 25% and this is 75%? Okay, so this 6 volt is 100%. Okay, so what will be 75% of the 6 volt? So point C will be 4.5 volt. So between C and D, okay, between C and D, the difference is 4.5 volt. So this is 4.5 volt. Clear? Then between A and C, A is 3 volt, C is 4.5 volt. If I put a voltmeter in between, the difference between A and C will be 1.5 volt. Are you all clear about this now? Did I try to make it easier to understand by using percentage? Can? If I don't use percentage, can I also use this? This is 10 parts. This is 30 parts. And then this is 40 parts. Okay? So the 6 volt is 40 parts. Then if you want to break down the 30 parts, you will know that the 30 parts will be 4.5 volt. Okay, which one you prefer? To break it down by percentage or break it down by ratio? Okay, let's continue. Okay. All this we just did recently, right? So I will just skip this question. Anybody want me to go through this question? Anyone? Anyone want me to go through this question? Okay, let me just go through some other. Okay, let's go look at this. Okay, let's skip this. Okay, let's do this one. But over 2 pages, very hard to see. Okay, for whole 2 page, I will not do this. We'll do the next question. Okay, let's do this. So who can try to draw a suitable circuit diagram? Who want to draw the diagram? Who want to draw the diagram? Nobody, ah? Okay, let me just share with you the answer. Okay, first you have a 12-volt battery. Okay, 12-volt battery. So I draw a 12 battery now. Can? And you have a potential meter, a potential divider. So I draw the potential divider here. Lor. Okay, so we have a A and a B. Okay, so you have to measure the current, okay, the current of the lamp. So I put a ammeter here, then my lamp is here. So whatever current that pass through the lamp, okay, it will be measured here. And then this current will be pointed to somewhere between the potential divider. Okay, and if you want to measure the potential difference of the bulb, you just need to put your voltmeter across it. Okay, that's how you do this. That's all. Simple. Is it simple? Okay, this is your 12-volt battery. Okay, so let's do the question. How does the student gradually increase the lamp in increase the current in the lamp from 0? Okay, so you just need to slide from B. When your this slider is at B, right? There'll be no current. Then you slide up all the way to A, it'll be maximum 12 volt. Is that clear? When it's at B, you'll be 0 volt. When you slide out the way to A, it's 12 volt. So you just slide the okay, slide the contact from B to A to increase the current. So next question is, why the potential difference across the lamp is not proportional to the current in it? Okay, by right, it should be proportional. Okay, by right, it should be proportional because the resistance of the lamp is equal to V over I. So this should be constant. Your voltage and your current should be the difference, okay, the division here, should be constant. Your resistance should be constant. However, okay, in this case, it says that it is not proportional. It means that your resistance is not constant. And the only reason is because, okay, the only reason is because you can write down the lamp is a non-ohmic conductor. Is that clear? It's not ohmic. If it's ohmic, it will actually follows Ohm's law. This is Ohm's law. V equal IR is Ohm's law. But because it is non-ohmic, then it will not follow this law. Is that clear? Okay, last question. Let's do B1 and B2. If you get the correct answer, okay, you may leave. Okay, last question. Once you got this question, I'll dismiss your Okay, there's more question to this, right? Don't have. Okay, let's do. Okay, let me see your working. How Ray, your one is correct. How Ray, you may go. You think your one is correct. Oscar, your one is correct. How about the rest of you? Bei Kwan, your one is correct. Oscar, your two is incorrect. Try again. Okay, Oscar, you may go. Bei Kwan, what's your answer for? Okay, Bei Kwan, your one is correct. Well done. So let me just write down the answer for part one. Okay, so basically, let me just zoom in a bit more. Okay, so the formula you need to know is Q is it. Okay, your I is 0.20. Your T must be in seconds. Okay, T must be in seconds. Okay, you must change this to second. 4 times 60 is 240 seconds. So you must multiply by 240 seconds and you will get the answer 48 coulomb. Okay, so now can you all do part 2? Yuting, you may go. Oscar, you may go. Okay, Bei Kwan, are you able to do part 2? Bei Kwan, are you having a problem? But there's no resistance in the question, so you might use something else. Okay, what's the formula? What's the formula you need to use? Voltage is W over Q. Okay? Your W is your energy or work done. Your Q is this. So now you do this, you sub in, can you get the answer? Okay, try again, Bei Kwan. Okay, so this W that you see here is work done. So the amount of work that is done from 390 joule, what is the amount of work that is done? Okay, please write that down. Okay, well done. Okay, so from here, you'll be able to get the answer. 390 joule over 48C. Okay, you will get 8.125 volt. But because your answer cannot be so precise, you change to 8.51 volt, you write down 2 SF. Okay, Bei Kwan, are you clear? Are you clearer now after today's lesson? I'm still worried for you. Okay, Bei Kwan, you may go. Yiting, you're still here. Do you need any question for me? Yiting, are you there? Any question for me? If not, let me end the lesson now. Thank you, everybody. So I'll see you next week. Okay, good night and goodbye.